For this solving of a system, for number one here, what we need to be able to do, in this case, is since we have y equals something and y equals something, this is like y1, this is y2, and if we're looking at this point right here, that xy, the x and the y are going to be the same points on in each of the equation. So it'll be true in each one, because that point's going to be on each one. So now, if that's the case, and since we're looking for this point right there, we can say that y1 is equal to y2. And whenever you have y equals and y equals, easiest thing to do is just set up negative 2x minus 3 is equal to x plus 3. Because in this case, that's what we're going to end up with. Those y's have to be the same value. So now, we solve for x. First step, I want to keep x's positive, since I like positives. I'm going to add a 2x using the reflexive property to both sides. So I'll get negative 3 is equal to how many x's? 3x's plus 3. Subtract a 3 here. Subtract a 3 here. Get negative 6 is equal to 3x, because all we're doing was adding in that case. Then divide by that 3. And x is equal to negative 2. So I got an x-coordinate of a negative 2. And I know I did this one earlier, but then I messed up at that point for some people. I'm going to use, since I need a y, and whether I put a negative 2 into each one of these, I'm still going to get the same value for y. I'm going to use the easiest equation I can, which is the second one right here. So I'll say y is equal to x plus 3. I know my x is a negative 2. Y is equal to negative 2 plus 3. So y is equal to 1. 1 is my point. So I know I did help some people, and I do apologize if that led to any issues. But that's what you end up having to do. When you have y and y, y is equal to y. Because whatever point you get here, x1, y1, and x2, y2, your x1 is going to be equal to x2, and your y1 is going to be equal to y2. And so we go off of that idea, because it's going to be the same point. So this was a substitution problem. The second problem here, I'll scoot it over a little bit, is another substitution problem. And the fact that I know that y is equal to negative x minus 2, and there's a y, I can substitute that value in for y, and what I'll get here is 2x minus negative x minus 2 is equal to 2. So that was my y value, and I just substituted in from the first one. So now I have to distribute a negative sign, which means it's going to change the negative x to a positive x, negative 2 to a positive 2. So I'll get 2x plus x plus 2 is equal to 2. So I'll get 3x plus 2 is equal to 2. Subtract the 2 from both sides. I get 3x is equal to 0. Divide by 3. X is equal to what? 0. So I know the point is 0 comma something.
I'll leave this here because I'm curious as to whether you know a factoring technique to get. This is what I started with. Simplified to that. This is its final factored form.
Oui.
I want to know now.
Okay.
Like what's the factoring?
All right. I like those. All right. So now I know my x is 0. What do? I know x is going to be 0 in this equation, x is going to be 0 in this equation. Which equation is the easiest one to use, the first one or the second one? The first one, because I have y isolated by itself. That's negative x minus 2. If I put in a 0 for x, I get y is equal to negative 0 minus 2. What's negative 0? 0. X is equal, or y is equal to negative 2. I get a negative 2 as my value. There's my point of intersection. That's my solution. So for both of these, we're good to go on both of them.